In today's lesson 26.1, we're going to be talking about radical regressions. So we're going to be finding a model that best fits a set of data. Now, all of our models today are going to be some kind of radical function, so either a square root or a cube root. So we're starting in our Springboard book on page 403. You're going to need something to write with, and you're going to be using Desmos today, so make sure you have that tab open. Okay, so we're starting on page 403, and we're going to be looking at this set of data here. So this says a physics class conducted an experiment comparing the period of a pendulum to the length of the pendulum. So the length compared to the time, okay? So they had us make a scatter plot of this data, okay, and talk about what the best fit model would be. Now we've done regression lines before, our best fit lines with parabolas, but if you look at these points here on the scatter plot, it's not making a parabola shape. This more is resembling the parent function that is a square root function. So we've talked a little bit about their graphs before. So it's a square root function. Okay. Remember the square root function, square root of x, our parent function, started at the origin and then kind of had this shape to it. So that's kind of the picture they're showing you here. Now, when we talk about a square root regression, remember, a regression is just a model that best fits the data. It's not going to be completely perfect, okay? But it's the process of finding a function that fits those points on our graph. So you can see it doesn't go through every point perfectly, but it's a good fit for the data, okay? So I'm going to show you how to do this on Desmos. We're going to do some square root and some cube root ones, but I'm going to start by just using this data here. So we're going to write a function, okay, a square root function, a radical function that we could use to predict any kind of length and time for this data. So we're going to pull up Desmos, okay, and I'm going to share this link in Google Classroom with you, so if you need it, you can pull it up too. But what we're going to do is we're going to take our values, okay, that we have, okay, let me go back to our Springboard book here. So I'm going to take the length and put that in for x, because that's what our x-axis here is labeled, length for the x values, put in the time for all of our y values. So if I go back to Desmos, x1, I'm going to put in all of those values. So it's 6, 10, 14, 18, 22. Here's all the values from our x side of our table. So now if I put in all the times, make sure your two sides line up so that way you didn't miss any values. But you can see ours has like kind of a different window, but it is giving you that radical shape. Now, we like the scatter plot and it's good to kind of visualize, but what we really care about is this part down here. It's going to show you how to write the equation. So our general form here is y equals a times x to the b power. Let me go back. General equation is y equals a times x to the b power. Okay. So let me go back to our Desmos and see what we get. Okay, I'm just going to screenshot this, I think, so I can put it on our notes and just look at it there. This is what we get from Desmos. So if we're looking at this function, the a value they're saying is like about 0.33. Let's just use those values. I round that up, 0.33. X is our variable. Now the b is 0.49. So this is basically about a half. So we think of this as x to the 1/2 power. Now I talked about this a little bit in class, but anytime you have something to the 1/2 power, that's just another notation for writing a square root function. So really our function and how we like to look at it is going to look something like this. 0.33 times the square root of x. So the b is always going to be a decimal here, so you just kind of have to translate what that decimal means. If it's close to a half, that's a square root. Now you can tell it's not perfectly a half because remember this is a best fit line. It's not going to be perfect all the way, but that's how you do these. Okay. If you're using a graphing calculator, the steps are an example C here where they're using the statistics. But for us, it's just easier to put it in Desmos since we're comfortable with using that. So it's always going to give you an a value. Okay, so here is our regression equation again. The A value is going to be our coefficient. The B value is going to tell us what kind of radical we're using. So if your B value is very close to a half, it's a square root function. If your B value is close to 0.33, which is a third, then it's a cube root function. So your job is to kind of translate that B value to know what kind of radical we're looking at. But it's only going to either be 1/2 or 0.3. So square root, cube root. Okay. So I made some examples for us to practice on the next page. So you don't have these on your book. So you might want to pause here and kind of write them in. But I'm just going to kind of go over how to type it into Desmos again and get our regression equation. So let me go back to Desmos. Now I have these written down on a paper in front of me. That's why I don't have to switch back between my two screens. But let's clear these out. On my x values, I'm going to put all my x from the table. So all the x values in x1s, all the y's in the y column. Okay, so let's do that really quick. I have 1, 2, 4, 16, and then my y values were 1, 1.2599. The more decimals you put in there, the more accurate you're going to get from your reading. But here's what Desmos gives us. So again, let me just kind of screenshot this and put it in our notes. So for number 1, remember our general form, if I write it on the top here, is a x to the b power. This is why we call this a power regression, because it's our b value is an exponent. But tells us our a value is 1 and our b value is 0.33. So remember, if it's a third, that means our b value is telling us we have a cube root here. So when I rewrite this as a function, I have y equals, my a value is 1 times the cube root of x. Okay, where in this case, since it's just 1 in front, we could just write cube root of x like this. Okay, so again, instead of writing it a times b to the 1/3 power, we're going to translate that 1/3 into a radical. So if it's 1/3 is a cube root. Let me try to do it one more time, and then you guys will try one, and then that's it. So in number 2, we have our x values. We're going to put in Desmos with our y values. Okay. So again, I'm going to go back to Desmos, clear out my table. And re-enter my x values. Well, I guess I could have kept those. So 1, 2, 4, 8, 16 for x. My y values were 3, 4.2, 4, 2, 6, 6. Okay, so there's my scatter plot, but again, I don't really care about the scatter plot as much as I care about what Desmos gives me for my equation. So let's go back to our notes, put that in. Okay, so what it gives us here is our a value is about 3, 2.999 repeating. So we'll say a is 3. Our b value is 0.5, so our b value is a half. Okay, so what that tells me, if it's 0.5, then that's the square root of x function. So when we put this in, it would be y equals a times x, so 3 times x to the 0.5 power. So we just kind of have to translate what that 0.5 means. This means we have 3 times the square root of x. Okay, so again, in these problems, you're either going to have a square root or a cube root. So the only number you're really going to have is your coefficient. You're going to translate that decimal, the b value, into what type of radical you have. So 0.5 is a square root. 0.33, a third, is a cube root. So I'm going to have you guys try this last one. The x values are all the same, so you just type all those into Desmos. Change your y values out in your tables to be these values. Again, I linked Desmos in the assignment, so you should be able to find this exact page set up for you with the table and the equation typed in already. So all you have to do is punch your table in and translate what Desmos gives you. Okay, so try this last one and see what you get. Okay, if you did everything right, your Desmos should have spit out that the A value is about 5. Your B value is 0.33 repeating. So our equation here would be 5 times x to the 0.33 power. So that means our equation here would be 5 times the cube root of x. Okay, and that's how we do power regression. So you're letting the calculator do all the work. The only work you're really doing is translating that B value. What type of radical are you getting from that decimal?